we were looking at the Solow model. We discussed the setup where we looked at the production function and the capital accumulation equation. We now want to look at how do we convert the production function in per worker terms. The idea is that the production function y is equal to fkn satisfies constant returns to scale, where we talked about what constant returns to scale is, where the idea is that if we scale all inputs by some amount, output gets scaled by that same amount. So multiplying both arguments by any positive constant c causes output to change by the same factor. So we have assumed the production function satisfies this property known as constant returns to scale. Now, this assumption of constant returns to scale allows us to rewrite this production function y is equal to fkn in per worker terms. Instead of writing output is a function of capital and labor, we want to write that output per worker is a function of capital per worker. Now, and here what we're using to rewrite it is the constant returns to scale assumption. And like we said, recall that the constant returns to scale production function satisfies this property. Mathematically, we can write constant returns to scale like this. It's saying that if we change both of our inputs by some amount c, then output gets scaled by that same amount c. So what we're going to do is, in order to rewrite our production function in per worker terms, so we're going to choose this c to be 1 by n. Then we can rewrite our production function. Y is equal to fkn is this. So we have y is equal to fkn, we're just dividing both sides by n. Right, so then we're just dividing both sides by n. And then we know, so here we just divided both sides by n. And now we know that because this production function satisfies constant returns to scale property, so we know we can write fkn by n. Here this c is just 1 by n, right? So then we know, okay, this means that we can rewrite it like this, right? 1 by n, 1 by n. Here, and given that it's a constant returns to scale production function, here we're just choosing c to be 1 by n. So we know y is fkn, divide both sides by n. So after this, what we can do is we can rewrite this in this form using this constant returns to scale property where we're choosing c to be 1 by n. And then this can be simplified as fkn1. And then we can just simply define capital F k by n1 to be equal to small f k by n. The number 1 is a constant and this can be ignored. So our per worker production function is that output per worker is a function of capital per worker, right? So the idea is that output is a function of two things, capital and labor. But when f is constant returns to scale, it satisfies the assumption of constant returns to scale. We have seen that we can write output per worker as a function of capital per worker, right? So using constant returns to scale. So given output is a function of capital and labor, but if it satisfies constant returns to scale, then we can write it in per worker terms, output per worker as a function of capital per worker. So the interpretation of this is that output per worker is an increasing function of capital per worker, right? So we have output per worker is a function of capital per worker. So it's an increasing function, whereas capital per worker increases, so does output per worker. And the decreasing returns to scale of capital remain unchanged even with this manipulation, because one of the assumptions we made was that, okay, one of the assumptions, we made over here was that we have decreasing returns to capital, which means that increases in K with fixed N lead to smaller and smaller increases in output. So now, even after this manipulation, the decreasing returns to scale of capital remain unchanged. We know, okay, output is increasing, but at a diminishing rate in K. This is the assumption we made. Okay, increases in K with fixed N lead to smaller and smaller increases in output, right? So FKN is increasing, but at a diminishing rate in K. This means that output per worker is increasing, but at a diminishing rate in capital per worker. So increases in capital per worker does lead to an increase in output per worker, but it leads to smaller and smaller increases in output per worker. So our per worker production function inherits the diminishing marginal returns of capital from our production function, right? So when we say, okay, we can rewrite a production function per worker term, we can write output per worker as a function of capital per worker. Here we need to remember output per worker is an increasing function of capital per worker, but the decreasing returns to scale of capital remain unchanged, which means that output per worker is increasing, but at a diminishing rate in capital per worker. So when you increase capital per worker, output per worker increases, but the increase becomes smaller and smaller as you keep on increasing capital per worker. So the per worker production function inherits the diminishing marginal returns of capital. And here it's just important to remind ourselves that if a production function does not satisfy constant returns to scale, we cannot write the production function in per worker terms, right? Because all of this analysis that we did here, where we showed that the production function can be written in per worker term is under the assumption of constant returns to scale. Because here to go from this step to this step, we're using the constant returns to scale property, right? So this step fk, to go from this step to this step, is where we have applied the constant returns to scale property, because over here we just choose c to be 1 by n. So if a production function does not satisfy constant returns to scale, we will not be able to write it in per worker terms. So now let's look at if given a specific functional form for constant returns to scale production function, how can we write it in per worker terms? To write it in per worker terms, we just simply divide both sides of the production function by n. Suppose we have this production function where we have k and n both to the power 1 by 2. We want to write it in per worker terms, i.e. we want to write output per worker as a function of capital per worker. For this, we take our production function, which is y is equal to k 1 by 2 and 1 by 2. We divide both sides by n. And then we use an indices rule and write this as y by n is k 1 by 2 power n 1 by 2 using indices rules. And then using another indices rule, we can write this as y by n is k by n power 1 by 2. So we're using this indices rule here. And here we can just redefine capital Y by n to be small y output per worker, and capital K by n to be small k capital per worker. And we can write small y, which is output per worker, is equal to small k, which is capital per worker, to the power 1 by 2. So we've written output per worker as a function of capital per worker. So the recommended notation here is to use uppercase letters to denote aggregate variables. So capital Y is aggregate output, capital K is aggregate capital N is aggregate labor. And we'll use lowercase letters to denote per worker variables. Like small y is output per worker, small k is capital per worker, as we defined over here.